Hello, today I'm going to be solving lesson 5 of, or problem 4 of lesson 5. So, to start off, we know that this function is not continuous. So, we must first factor the denominator. By doing simple math, we know that x minus 6 and x plus 6 is the same as this equation, or as this there. So we can go ahead and cross out the x minus 6, and what we're left over with is f of x equals 1 over x plus 6, since the x plus 6 is in the denominator. But this is only applicable if x is not equal to 6, because we need to find the disparity. So if we graph this, we find the asymptote here, -6. We know that this is always approaching an infinity, but once it hits 6, well, let's put 6 here actually. We find that the discontinuity at x equals positive 6 is removable, because if we plug in x to this equation, we find that it is 1 over 12. So simply just assign x to 6, and this is the removable discontinuity, because if you were to plug in -6, we would get 0, which would make this function continuous. Okay, so in order to solve this equation, we must first understand what it is asking. Find a so that f of x will be continuous. So let's go ahead and do that. So if we were to plot 1 minus 3x on the graph, we see that the slope is -3 and the y-intercept is 1. So let's say we were to put 1 here, we would start going down on the slope. And we're supposed to stop at the point where 4 is greater than x. So let's say we were to plug in 3.999. In this case, we'll just plug in 4 to make it easier. 1 minus 3 times 4. It would be -11 or -10.999999999. So here we are, -10.9999999 here. So our slope ends right around here. So now we must find the value for a so that the function f of x will be continuous for all of x. So in order to do this, we make ax squared plus 2x minus 3 equivalent to negative 11. Then we simply plug in our x, which is 4. 4 again. Solve this. So 4 squared is 16 plus 8 minus 3. Combine like terms. 8 minus 3 is 5. So 16a plus 5 equals negative 11. Subtract from both sides. We're left with 16a equals negative 16. Divide on both sides. And we get a equals negative 1. So, in order to make this continuous here, a has to equal negative 1. So, we plug in negative 1 to the equation. We're left with negative x squared minus 2x minus 3. That is the solution. Let's go to solve this equation now. So, to solve this equation, we must first understand that in order to find the vertical asymptote, we must find the point in which y is equal to 0. Well, that would be simple. We just made the denominator equal 0. We can do this by putting negative 1 as x. However, this is not a vertical asymptote, and let me show you why. If we were to plug in negative 1 into a limit that approaches negative 1 from the left side, we would have this equation here. First, we must solve for the numerator, which is x minus 1, and x plus 1 over x plus 1. And we're left with, so if x were equal to 2 in this equation, negative 1 minus 1 over 1, we would get negative 2. But since we're approaching the 1 from the right side, then that means that it would be far outside of the range, which would leave a hole. So, we see here at negative 1, there's a hole here. So to summarize, you cannot divide by 0. So if we were to plug in negative 2, or I'm sorry, let's do negative 1 to this equation. Negative 1 squared minus 1. Negative 1 plus 1. Both sides is going to equal 0. Therefore, the function has no value, no defined value. Okay, here we are, lesson 7, problem 4. So, in order to find the derivative, first we must find that the limit is actually equivalent to delta x over 0. If we plug this into the equation, we actually find that f x plus delta x, minus f of x is over delta x. This also equals 3 x plus delta x plus 2 minus 3x plus 2. If we do basic algebra, find out this times this, plus 2, negative goes to both of those. We'll find that we're left with the limit delta x when it's approaching 0 is actually equivalent to 3, because 3 over delta x over delta x cancels out, and you're left with 3 over 1. And that is the answer.